Alright, let's talk about something that sounds like pure science fiction, quantum tunneling on a scale you can actually see. I know, quantum stuff usually feels like it only happens in the tiniest corners of the universe, single electrons, atoms, doing their weird dance. But, what if I told you, we can spot tunneling with billions of particles, at once? So, here's the backstory. This year's Nobel Prize in Physics went to John Clarke, Michel Devoret, and John Martinis. They pulled off something that had never been done before. They built an experiment where quantum mechanics burst out of the microscopic world and showed up on a chip you could hold in your hand. Let's break this down. Quantum tunneling is this wild phenomenon where a particle, like an electron, can pass through a barrier it shouldn't be able to cross, almost like walking through a wall. In the past, scientists saw this with single particles or just a handful. These laureates created a superconducting electrical circuit on a chip about 1 centimeter in size. In a superconductor, you get things called Cooper pairs, pairs of electrons that move together, almost like dance partners without resistance. And we're not talking about a few of them. We're talking billions, all moving in sync across the entire chip. Here's where it gets cool. Instead of watching one or two particles tunnel, the whole crowd of Cooper pairs did it together. Imagine a stadium packed with fans, and suddenly everyone slips through a locked gate without breaking it. To make this happen, they cooled the chip to nearly absolute zero, so cold it's hard to imagine. At that temperature, the superconductor comes to life, and quantum rules start to dominate. The circuit had an energy barrier separating two states. Classically, Cooper pairs can't cross, but quantum doesn't care. They watched as billions of pairs collectively tunneled through the barrier. And they didn't just do it once, they could flip back and forth between the two states like a quantum seesaw, all because of tunneling. It was the first time tunneling and energy quantization played out with so many particles at once, on a device you can build and measure. Why does this matter? It's a huge leap for quantum technology. We can start harnessing these effects in real devices, like quantum computers, impacting medicine and cryptography. Quantum isn't just for tiny stuff anymore. Thanks to clever engineering and curiosity, we're watching quantum wonders unfold at a scale you can actually see.